today's experiment, we are dealing with buoyancy. Buoyancy is defined as the buoyancy force equal to gamma times the volume of that object. Our question today we're trying to figure out is find how deep the board will go, given the weight on the end of the board. This is our board, and this is the weight. It is circular. It is weighing in at a little over half a kilo, and we also have two trials at the moment, but in this video we will only be showing you one. First off, in this experiment we had to find out our theoretical values of what we're actually going to be doing. So we start off with our free body diagrams. Our first one is of the wood, so you have the tension of the string that holds the weight plus the weight of that board pulling down. You have the buoyancy force going up of the wood. Our second one of the weight, you have the weight of the actual metal going down. You have the tension on the string plus its own buoyancy force pulling up. For our equations, we found buoyancy force of the wood equal the tension plus the weight, which is also gamma of water times the volume of our wood equal to tension plus gamma of the wood times volume of the wood. We found gamma finding the density of our wood given our weight and lengths. With the weight, our equation becomes tension plus the buoyancy force of the weight equal to that weight of the metal circular piece. Our final equation becomes tension is equal to gamma of the weight times volume of the weight minus gamma of water times volume of the weight. Once we do this, we find tension here, which comes out to be 4.145 newtons, and we can plug that into our first equation of the wood. This makes our depth of how far the wood we predict is going to go to be 0.55 meters. Now I'm going to go to the water, and I am going to physically test this out with the weight attached with nails, string, and the wood, and I have a measuring tape with me to mark. Okay. I'm going in the water in 3, 2, 1. I will be balancing the wood so it doesn't tip over. I am not holding it, I am just keeping it steady while I make my mark. Okay, as you can see, I have made my mark. It is right here, and I will now measure it. So when I measure it in centimeters, it comes out to be 53 centimeters, as you can see right here. So our prediction of 0.55 meters is only 2 centimeters off of the actual value. So as you can see, our math is less than 10% off of what we predicted. And we have done a second trial, which our math has come out, our theoretical became 0.314 meters, which we used a lighter piece of wood, but it had a bigger surface area, and the actual turned out to be 0.345 meters. This test of buoyancy is now concluded. Have a nice day.